Imagine our solar system as a giant neighborhood. The sun is in the middle, and planets like Earth are circling around it. But planets are not the only things out there. There are also smaller objects called asteroids. Think of them as big space rocks. They are leftover pieces from when our solar system was first formed, billions of years ago. These asteroids are mostly made of rock, metal, and other minerals. They come in all sorts of shapes and sizes. Some are as small as a pebble you might find on the ground, while others can be as big as a whole city or even a small country. They are truly ancient travelers in space. These space rocks don't just sit still. They are constantly moving, orbiting the sun just like Earth does. Most of them live in a special place between the planets Mars and Jupiter. This area is called the asteroid belt. It's like a giant cosmic highway full of these rocky bodies, all following their own paths. Sometimes, though, their paths can change. A little nudge from Jupiter's gravity or a bump from another asteroid can send one flying off in a new direction. Sometimes, that new direction can bring it very close to our home planet Earth. It's a cosmic game of pinball, and Earth is one of the targets. Now, it's important to remember that space is incredibly, unbelievably big. The chances of an asteroid actually hitting Earth are very small, but they are not zero. These rocks have been a part of our solar system's story for a very long time, and they have hit Earth before. In fact, they played a big role in shaping our planet's history. The craters we see on the moon are scars from past impacts, and Earth has its own scars too, though many have been erased by weather and time. Understanding what these asteroids are and where they come from is the first step in understanding our place in this vast, dynamic universe. So, an asteroid is essentially a rock floating and flying through space. It's a remnant from the birth of our solar system, a silent witness to cosmic history. Most keep their distance, minding their own business in the asteroid belt. But every now and then, one gets knocked off course and heads our way. They are a natural part of our cosmic environment. They are not evil monsters from a movie. They are just following the laws of physics. And because we share this space with them, it's really important for us, the people of Earth, to pay close attention to them. Science helps us do that. What happens when a small asteroid decides to pay Earth a visit? Well, most of the time, something amazing happens. Our planet has a protective shield called the atmosphere. It's a thick blanket of air that surrounds us. When a small asteroid, maybe the size of a car or a basketball, enters this atmosphere, it's traveling incredibly fast. The friction between the fast-moving rock and the air creates an enormous amount of heat. This intense heat causes the small asteroid to burn up and glow brightly. We see this from the ground as a beautiful streak of light across the night sky. We call it a shooting star or a meteor. Most of these small space rocks burn up completely long before they ever get close to the ground. They turn into nothing more than tiny dust particles that float down gently and mix with our air. This happens all the time. In fact, thousands of these small objects enter our atmosphere every single day. We just don't see most of them because they are too small, or they happen during the daytime or over the ocean where no one is watching. So, our atmosphere acts like a strong security guard, protecting us from the constant shower of small space debris that comes our way. Sometimes, a slightly larger piece might not burn up completely. A small fragment of the original rock might survive the fiery journey through the air and actually land on the ground. When a piece of an asteroid lands on Earth, we give it a new name, a meteorite. These meteorites can be very valuable to scientists. They are like free samples from space, delivered right to our doorstep. By studying them, we can learn more about what asteroids are made of and get clues about the early history of our solar system. Finding a meteorite is like finding a very old, very special rock from outer space. So for the most part, small asteroids are not a threat. They create the beautiful shooting stars we make wishes on. They are a constant reminder that we live in an active and exciting solar system. Our atmosphere does a fantastic job of protecting us from these smaller visitors. It filters out the cosmic dust and turns potential impacts into harmless light shows. It's a natural defense system that works around the clock, keeping our planet safe from the constant barrage of small space rocks that are traveling through our cosmic neighborhood. Now let's consider something much bigger. What if an asteroid the size of a mountain or a large city were on a collision course with Earth? This is a very different story. An asteroid this large would not burn up in our atmosphere. It would punch right through it and hit the planet's surface with unimaginable force. The impact would be more powerful than all the world's nuclear bombs combined. It would create a massive explosion, instantly vaporizing everything at the impact site and creating a gigantic crater, miles and miles wide and deep. The shock wave from this blast would travel around the world. If this large asteroid were to hit land, the consequences would be catastrophic. The impact would trigger massive earthquakes that would shake the entire planet. It would also throw enormous amounts of dust, rock, and soot high up into the atmosphere. This thick cloud of debris would spread around the globe, blocking out the sun's light. Without sunlight, temperatures on Earth would drop dramatically, leading to a long dark period known as an impact winter. Plants would not be able to perform photosynthesis, and they would die. This would cause the entire food chain to collapse, affecting all animal life. What if the asteroid hit the ocean? Hitting the water wouldn't make things any better. In some ways, it could be worse. The impact would create a colossal tsunami, a giant wave hundreds of feet high. This mega tsunami would travel across the ocean at the speed of a jet airplane, crashing into coastlines around the world. It would wipe out coastal cities and cause unbelievable destruction far inland. The impact would also vaporize a huge amount of seawater, sending it into the atmosphere along with rock from the seabed, contributing to the same sun-blocking dust cloud and triggering that devastating impact winter. For humans and animals, survival would be extremely difficult. The initial blast, earthquakes, and tsunamis would cause immediate and widespread loss of life. But the long-term effects of the impact winter would be the greatest challenge. With plants gone, herbivores would starve, and then carnivores would follow. For humans, agriculture would become impossible. The darkness, the cold, and the lack of food would create a world that is very hard to live in. This is what scientists believe happened to the dinosaurs about 66 million years ago. A large asteroid impact changed the world so drastically that they could not survive. The idea of a large asteroid impact is scary, but here's the good news. People are watching the skies. Scientists all around the world are our planet's guardians. They use powerful telescopes on the ground and in space to scan the sky every single night. Their job is to find, track, and study asteroids, especially the ones whose orbits bring them close to Earth. These are called near-Earth objects, or NEOs. By watching them carefully, scientists can calculate their paths for many years into the future. This allows them to see if any of them pose a real threat of hitting our planet. When scientists find a new asteroid, they share the information with other astronomers around the world. Everyone works together to observe the object and refine its orbit. The more they observe it, the better they can predict its exact path. This global teamwork is essential for planetary defense. It's like a neighborhood watch program for our entire planet. So far, they have found and catalogued most of the very large asteroids that could cause a global disaster. And thankfully, none of them are on a collision course with Earth for the foreseeable future. But what if we did find an asteroid that was going to hit us? Scientists are not just watching, they are also working on ways to protect Earth. They are developing and testing technologies that could change an asteroid's path. One idea is a kinetic impactor, which is basically a heavy, fast-moving spacecraft designed to crash into an asteroid. The goal isn't to destroy it, but to give it a small nudge. Over a long distance, even a tiny nudge can be enough to change its course so that it misses Earth completely. NASA recently tested this idea with its DART mission, and it was a success. Learning about asteroids is incredibly important. It's not just about preventing a disaster, it's about understanding our solar system and our place in it. These space rocks hold secrets about how planets, including our own, were formed. By studying them, we learn about the history of our cosmic home. And by developing the technology to protect ourselves, we are taking responsibility for our own future. We are the first generation of life on Earth that can actually do something to prevent a major impact event. That's a powerful thought, and it's all thanks to science.